Hi, this is Mrs. Reed. Welcome to Physical Science and Physics. Today we're going to be talking about linear measurement. All right, so linear measurement is talking about just how long or how far is that. So first let's talk about the two kinds of measurement. First, you have standard measurement. Standard measurement is in inches, and inches are divided into halves, fourths, eighths, sixteenths, and even 30 seconds on some rulers. So for standard measurement, what we use here in the United States, fractions are incredibly important. And the way you would look at this is 3 inches. This mark would be 3.5. This mark would be 3 1/4, 3 1/8, and 3 1/16. So if you had to get to where my cursor is, you would count by 16ths every tick mark. So that would be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sixteenths, and then you would reduce that. The other side of the ruler is in centimeters, and centimeters are divided into tens, and they're divided into millimeters. So every tick mark between the 1 and the 2 is 1 millimeter. So for the metric system, which is meters and centimeters, decimals are incredibly important because it will simply be 2.1, 2.2, 2.3, 2.4 centimeters. So on your formula sheet, we're going to add some abbreviations. Abbreviations you have for length are inches, feet, miles, kilometers, meters, centimeters, and millimeters. Be very careful that you don't try to abbreviate miles and meters because those are two very different things, both with an M. Be careful that MI is miles and M is meters. Some abbreviations we'll also use for time is seconds, minutes, and hours. Be sure you get these on your formula sheet. The second thing you need to put on your formula sheet is a conversion chart. These are conversions that are going to be standard from one thing to another. So 1 inch is equal to 2.54 centimeters. 1 meter is 100 centimeters. 1 centimeter is 10 millimeters. 1 kilometer is 1,000 meters. 1 foot is 12 inches. And 1 mile is 5,280 feet. Those are going to be the only conversions you will use in this class for length or measurement. For time, remember that 1 minute is 60 seconds and 1 hour is 60 minutes. And eventually we'll be doing what's called dimensional analysis that needs unit conversions, but I'll help you with those. So let's look at how far something actually is. If we want to measure the red line, you may have to zoom in and get a little bit closer. I'm looking at this red line lining up with this place right here. Notice that my ruler is in centimeters, so I'm going to go to the whole number and then decimals are important. This is 3.1, 3.2 centimeters. But if I wanted to measure this in millimeters, instead of saying 3, it would be 32 millimeters. Again, look at this one. This is in standard measurement. Notice that we're trying to measure the metal rod. Okay, I'm looking at this going to this position right here. So when we look at that, notice that this is 11, This is 1 foot. So this measurement in here is 11.5. Okay. So this ruler actually looks at, this is the half, the fourth, the eighth coming down. This is the 16th and the 32nd. So if we go to measure, this would be 11, and counting all the way down to the 32nd, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 32nds. If you reduce that fraction, you get 7 sixteenths. 11 7/16 inches. And you will have to measure in both metric and standard. So if we look at reading measurements, most of the time you'll be reading measurements straight off a tape measure. In order to read the measurement of each small mark, you have to do several things. Notice on this one, I might be able to read the first couple, but unless I get closer, I'm not going to be able to see them. So 1, get closer, and 2, know what measurement you're looking for. This one, since it's by tens, it appears to be in centimeters. So we're going to measure this in centimeters. So I'm going to zoom in and we're going to start reading this. First, notice that there are 4 tick marks between 10 and 11, or between the 1 and the 2. There are 4 marks. That means that this tape measure is measuring every 2 millimeters, or 0.2 centimeters. So since I'm going to measure everything in centimeters, I'm going to be looking at every tick mark being 0.2 centimeters. So these 3 measurements would start at 10, 17, and 24.4. Show you again. 10 would be the start, and then 17, and then 24.4. And keep going. These would be at 32, sorry it's a little blurry, 40, and what looks like 47. These would be at 54.6 and 62. These would be at 70, 77, and 84.4. I don't have to be exact, I just have to be close. Measuring is not a very exact thing most of the time. So, looking at these would be, now, notice this is 1 meter. So I know I'm before that, so this would be like 92.2 all the way down here. This would be 99.8, and this one would be at 107. 100 because there's 100 centimeters in 1 meter. If we keep going, since we're now in centimeters and we're past 100 centimeters, these measurements would be 114.6, 121.2, and 129. Finally, as we reach the end, way past 100, these last 2 marks, this one is our 129, but these last 2 marks would be 136.2 and 143.8. Now, in physics, we would put it all together in one really long data table, and I've wrapped my data table around because it wouldn't fit all on the screen if I didn't. But what you're going to do after you write down all of those numbers, we're going to look at them as if every mark was made each second. And so the first second, their first measurement was 10, 17, 24.4, 32, and so on. And we had actually 19 measurements all the way out to 143.8. So we copy our data into a Google Sheet, okay? And you highlight your data. In order to highlight your data, once you type the data in here or you copy it over, you type the data into a Google Sheet. Okay, this is graphing digitally versus graphing physically. And you have to highlight the data. You do that by clicking in the cell you want and just pulling the whole thing down. It should turn it a blue color. Then you want to insert a chart. You again can go to insert a chart, and it picks this weird column chart. You don't want that. You want to go to chart type, scroll down to scatter, and just close the chart editor. You can move the chart a little bit so that it's not on top of your data, and believe it or not, you're done. We'll do more practice on graphing digitally later. So now let's go back to our beautiful little thing. What would the next step be? That would be to graph it. Is there a pattern? Well, if you look at this, that's a pretty straight line. And we could estimate or whatever, where would it be at 11 seconds? Or at 9.5, or where was it at 0 seconds? Because the data table itself doesn't show us that. So we could use it to estimate. Part 2 of today's activities is dimensional analysis. This is being able to convert from one unit to another, right? So you need those conversions that you wrote down on your formula sheet. These are going to be in the form of single measurements, not a whole series of measurements like we just took. So, for example, in the measurement activity that I showed you just now, we measured in centimeters, and our last measurement was this 143.8, okay, centimeters. What would that be in inches? Well, you set up a conversion chart. Dimensional analysis is what this is called. You set up a conversion chart, and in order to get rid of centimeters, I have to put it on the bottom, and I will show you more of these in class. Put it on the bottom. Inches is what I want to change it into. So the conversion from my conversion table is 1 inch is 2.54 centimeters. Then I multiply across the top, 143.8 times 1, and divide by 2.54, and you get 56.6. You're going to be doing lots of activities in class the next 2 days. Thanks for watching.